Welcome everyone, this is Tutors. So last video we covered on our density logging and our neutron porosity log also. So we're going to look at how to solve questions using our total porosity, neutron and density combined. So there are conditions. This is a formula for wet sand. This is a formula for in hydrocarbon. So just take note of that. Okay. So for your density log, so remember for your density login, okay? So remember that you need to how we got our density log. So using this method now, kind of easy. So count the number of lines from the lower limit. So if this is your okay, let's take it bit by bit. If this is your reference line, you are counting lines from here. Abi? 1, 2, 3, 4, 5, 6. Then here is like 6.6, yeah, not 6.7. So multiply that 6.6 now, okay, by your what increment per line. Okay, our increment per line for our density is different from our neutron because what did I say to solve for your increment in the last video? You saw that upper limit minus what lower limit. Upper limit for this thing as is 2.65, abi 1.6 for density divided by what number of lines 10. So we have 1 divided by 10 and that's what 0.1. Okay, that's 0.1. So what did I say in the second thing to do? Multiply it by what? Your increment. 0.6 times what? 0.1. And that'll give us what? Sorry, 6.6 times 0.1. That's what? 0.66. That's what did I say? Add the result to the lower limit. So 0.66 plus what? Lower limit. What's my lower limit? 1.65. Have you? So add it to 1.65. What do you get? You get what? 2.31. Good. But recall that what? Your okay, record that your density, let me use a new page, record that your density is not direct unlike neutron, so you have to use your formula. So density formula is matrix minus density of matrix minus density bulk density. So what you've just gotten from that stuff, your 2.31 is your bulk density. Okay, so minus fluid. Okay, I've said that we're using sandstone, which is cut. So that why it's 2.65. We have 2.65 minus 1.00. That's how it's used for density of fluid. And here is 2.31. So we get 2.65 minus 2.31, 0.34 divided by 1.65 divided by 1.65. So that's 0.206. 0.206. Good. So E is for wet sand or hydrocarbon. Okay. So if it's for hydrocarbon, we're going to use neutron density is equals to square root of. Remember that what do we get for our neutron? We got 0.198, have you? So 0.198 square plus 0.206 for density square divided by what? 2. So take your calculator and you press everything inside. 198 square plus 0.206 square, okay, divided by 2, then square root of answer, you have 0.202. 0.202. Okay, that's for hydrocarbon. For wet sand, since the reference line is still the same thing, then your answer will still be the same, like your stuff will still be kind of, you're sticking to, since your readings will still be the same thing. But if the your reference line for your wet sand is different, let me see, you drew on that one that probably is closer, you're trying to average the game. You're trying to average the game. Average means that probably you try to move this line a bit so that it will fit in this place. So it will be half of what is here and what is here. But like this, it still kind of makes sense. But to just show a little bit, it will not really affect your results. Okay. So here will just be 0 point. Sorry, it doesn't have square roots. Wet sand doesn't have square roots. So let's say for wet sand here, we have for wet sand that's 0.198 plus 0.206 divided by 2. So what do we have? 0.198 plus 0.206 divided by 2. Okay, 0.202. Good. So we've come to the end of total porosity. So we can see how to analyze total porosity. So there's one stuff that I make use of is this. Okay. So they can ask you that what is the petrophysical implication? What's the petrophysical implication of your porosity? Okay, I told you that porosity is percentage, but we turn that on to decimal. So if you're stuck between 0 to 5%, it is negligible. If it's 5 to 10, it is poor. If it's 15 to 20, it is good. If it's 20 to 30, it is very good and excellent. Okay, greater than 30, excellent. So what do I do? 0.202 is 0 in percentage. That will be what? Times 100. Have it? That's 20.2%. That means our reservoir is very, very good. As it's a very, very good reservoir. Yeah, that's a nice porosity. Okay, so we've come to the end of the video. The next video we'll just talk about the summary of the kind of formulas and kind of things that you might probably need. Thank you very much for listening. Stay tuned. Kindly like and subscribe.